Facebook and Amazon are asking this question in the interview. We're given the array of intervals where each interval has start and end. We need to return the minimum number of intervals that we need to remove to make sure the interval is non-overlapping. For example 1, we can draw the graph from the given intervals array. So we have 1 and 2, 2 and 3, 3 and 4, and then 1 and 3. One thing to keep there in mind is that if we have the interval 1 and 2, 2 and 3, they are not considered overlapping despite this 1 that's connected at 2. So for this graph, we can take out 1 and 2, 2 and 3. The rest of them are 1, 3, 3 and 4, and they are non-overlapping. Or we can just take out 1 and 3. That makes those 3 intervals non-overlapping. And the question is asking to return the minimum number of intervals that we need to remove to make the rest of the intervals non-overlapping. So clearly in this case, we just need to remove 1. For the second intervals, we have 3 identical intervals, so we need to take out 2 of these. Next, I'm going to talk about a dynamic programming approach. Let's say we are given the unsorted array, and if we are looking for the graph here, we can see that the graph is actually sorted by the start point. So the first step is to sort the intervals based on the start point. Next, let's define the DP function. Because the question is asking to return the minimum numbers of intervals that we need to remove, it's actually the same as the maximum number of non-overlapping intervals. Let's look at the DP array. For the current item, we either keep the current item or we don't and choose the next item. But this is not good enough to build a consecutive DP function. We need to find a third point. If you're looking for the current item for the DP, it's actually equal to the nearest non-overlapping item plus 1. Because we know that 1, 2, and 2, 3, they are non-overlapping. So for the DP at index 3 here, if the DP is 1, and if we're looking for 1 and 2, that means 2 of them forms 2 non-overlappings, right? So at index 1, we have 1 plus 1, so we have 2. So DP value at index 1 is either equal to the DP value at index 2, that means we're skipping the first, or we keep the first and find out its nearest non-overlapping interval plus 1. So it gives us the DP relation that DP1 is equal to the maximum between DP2 or DP3 plus 1. Notice that DP3 can be different. It can be 4, 5, 6 or even 2 as long as it is the first interval that is non-overlapping with the DP1. And the way we check if there's overlap is by comparing the start point of the current interval with the end point of the last interval. Apparently the start of the current interval is less than the end of the last interval. So there is an overlap. So we can make the following if statement. If they are greater or equal to, then there is non-overlap. And this is the Python code. First, I sort the array by the start element. Because we are doing recursive function call, so I'm calling the cache function here to reduce the repeated calculation. The base case is returning 1 because if we have only one interval, that can make a 1 non-overlapping. I'm calling the DPI plus 1. That means we're skipping the current element and we only choose the next interval. Or we keep the current interval and we're trying to find the next non-overlapping interval. So by going through the array from I plus 1 until the last element, if we find there's a non-overlapping interval, we're calling the DP function based on that index and we break the for loop. In the end, we return the maximum between those two options. Because the DP function is defined as the maximum non-overlapping intervals, and the question is asking the minimum number of intervals that we need to remove. So it's actually returning the number of intervals we have minus the maximum non-overlapping intervals. For the time complexity, the sorting algorithm will take O and log n, and the searching will take O n. Now because we are trying to find the start point that's greater than the current end point, so we can actually perform the binary search, which will reduce the time complexity from n to log n. In Python, the bisect function can do the binary search in log n time. If you like this channel, please click like and subscribe. Thank you.